The dark web needs your help. So in this video, I'm gonna show you how you can become part of the dark web, which I know sounds kind of weird, right? But it's awesome. And within 5 minutes, you're gonna be running a server known as an onion relay. Yeah, the dark web's full of onions. And you're helping make the dark web possible, like you're helping it run. But why? Because isn't the dark web kind of a bad place? It can be, like all places, but it's also what millions of people around the world depend on to stay safe and anonymous online. The dark web is all about privacy, and that's where you come in. The dark web is kept safe by onions, or onion relays. Every single time someone tries to connect to anything through the dark web or the Tor network, an onion circuit is formed, consisting of 3 onion relays. These onion relays are just servers, but they do one really cool thing. Much like the layers of an onion, every time your data passes through the onion, a layer of encryption is added to your data, keeping your data safe and your identity anonymous. And by the way, there's a lot more to that, and it's kind of amazing, so if you want to learn more, check it out here. Now, your mission, should you choose to accept it, is to become one of these onion relays. Now, why you? Well, did you know that every onion relay is run by people like you, volunteers? Making this decision is a big deal and will have a pretty big impact. Every time an onion relay is added to the dark web, it gets better, it gets stronger. More relays mean faster speeds. The network itself will be more robust against attacks. It will be more stable, and it will be safer from spying. Now, I know you're probably wondering, is it safe to have a ton of unknown traffic going over your network through your server? Traffic that could potentially be illegal? Well, it depends. Mainly on what type of onion relay you choose to run, which there are different types, and where you put it. Can I tell you a dark web scary story? Get your popcorn and coffee ready. Popcorn and coffee. Is that any good? Let me try. Okay, let's see. It works, so go ahead and do that. By the way, this coffee popcorn break is sponsored by Dashlane. So here we go, with the help of Dolly 3, here's the scariest dark web story you've ever heard. So a hacker sneaks into Hackwell Industries. He plugs a USB into the server and gets all of the customer information. Usernames, passwords, the works. And then he puts it for sale on the dark web, like they all do. Now, changing scenes, we have the NetworkChuck team looking real classy. They're all working diligently and just happen to notice an alert in their Dashlane dashboard. Their password manager, and again, the sponsor of this video. Everyone was suddenly alarmed when they checked the message. Their usernames and logins for Hackwell Industries were all put on the dark web for sale. And this is like, that's coffee coming out of my body, exploding. They're hacked. But hold up. In a moment of clarity, NetworkChuck realizes, hey, thanks to Dashlane and their dark web monitoring feature, we were alerted and now we can take action before it's too late. So the team gets to work on changing their password for Hackwell Industries. Using Dashlane, they create a unique, new, complex password, not used by anything else. And Dashlane made that super easy. Thank you, Dashlane. But hold up, who's that guy over there? Alex, lazy Alex. Instead of changing his password, he's playing solitaire, daydreaming. And as NetworkChuck was checking his Dashlane team dashboard, checking up on the health of his employees' passwords, he notices that, hey, Alex is in bad shape. He's reused the same password multiple times, and he still has a ton of compromised passwords found on the dark web. So NetworkChuck knows exactly how to deal with this. Coffee on the head, it'll do the trick. So Alex, drenched in coffee, finally changes his password, and the NetworkChuck team, they're good to go. NetworkChuck then has a meeting with his team, just going over again the importance of secure passwords, and how it's the employees that are mainly the door into a company and how companies get hacked. And using Dashlane, they can change their passwords, check their password health, have them securely stored, dark web monitoring. It's awesome. The story doesn't have a happy ending. NetworkChuck forgot one thing, his remote employee, known as Nick or Florida Nick. Nick hasn't been using Dashlane at all. Here it is, Nick. Look at all that chest here. And has instead been writing all of his passwords inside a manila notepad. And without a password manager like Dashlane, there's no way if Nick knows his stuff is for sale on the dark web. He rarely changes his passwords, and they're probably all the same. So don't be like Florida Nick. Use Dashlane, again the sponsor of this video, and what the NetworkChuck team in real life actually uses to keep our passwords safe. You gotta try it out, link below, dashlane.com/NetworkChuck50, and make sure you do use that code, NetworkChuck50, and you'll get 50% off at checkout. And you can use Dashlane anywhere, I do, my phone, computer, all devices, and that's the end of our scary story. Looking back at our onion circuit, we have 3 types of relays. The first one is the guard, or entry node, the second is the middle, and the last one is the exit node. Now let me get this out of the way. You do not want to be the exit node, at least not right now. According to the experts on Reddit, the police could show up at your door, which happened to one dude here. Now, why does that happen? And that probably scared you, right? The exit node is the most exposed onion. Normally when you visit a website, this is you, you're Bob, and you're not using the Tor network, you're just going straight to that website, and that website knows who you are. It can see your IP address. But on the Tor network, it can't see you. That's the point, right? So it's going through a bunch of onions. But what that website can see is the exit node. So in this particular situation right here, that website thinks you are the exit node, but you're not, and that's what keeps your identity safe. The problem is that if you're running an exit node, and when I say you're no longer Bob, you are now Stacy, the awesome person running an exit node. So if Bob accesses something kind of sketchy, and the police maybe are trying to catch Bob at doing that sketchy thing, they're not gonna come after Bob. They're gonna come after Stacy because they see Stacy as the one accessing that website. So don't be Stacy right now. Don't run an exit node. According to the official Tor documentation, exit relays have the greatest legal exposure and liability of all the relays. And they're normally run by institutions and universities, people who are set up to deal with those kind of police knocking at your door situations. Normally they have agreements with the ISPs they're working with, and they know they're running a Tor exit node, and it's all good, they know. So unless you're an institution or university and you know what you're doing in that respect, you're probably gonna want to run the other two, the guard node and the middle node. Now the guard is the first stop, first onion in a circuit, and the middle is he's the middle child. No one pays attention to him, and that's perfect. That's what you wanna be, right? And that's what I'm gonna show you how to do. The guard and middle node relays hardly receive any kind of complaints of abuse, meaning like illegal activity going through them, because people don't see it. It's the exit nodes that are public and exposed, right? No one cares about the middle child, and the guard node is pretty much the same as far as exposure. And just so you know, when starting out, when you start running a Tor relay node, an onion relay, everyone's gonna be a middle relay. Everyone. You have to earn your way to becoming a guard. Over time, if you earn your stripes and you're consistent and you're awesome, you might be able to become a guard. But right now, we're all middle children, so sorry. Now the other big consideration is where are you gonna put it? There's really two places. Either you're gonna host it in your house on a spare piece of hardware like a Raspberry Pi, or any old laptop you have laying around, or a VM on a server. That's an option. And it's kind of cool because you're not even using it, right? And if you have extra bandwidth, go for it. The other one, and I prefer this, is you can run a Tor relay in the cloud. This is normally very low cost, $3 to $5 a month, and is much easier, and that's actually the way I'm gonna walk you through right now. And by the way, the steps I'll show you apply to the home as well. But if you do wanna run it at home, there are some system requirements you gotta be aware of. For bandwidth, your home network will need to be able to handle 7,000 concurrent connections. Now what does that mean? Well, it means that normal, run-of-the-mill routers, like this, I have one here. This little TP-Link router, it's not built to handle a ton of things. So your router may kind of sweat a little bit, but it's just a trial and error. You can test it out. But again, if you're running it from the cloud, you don't have to worry about anything at all. The cloud will just handle it for you. As far as bandwidth, it's recommended that you have 16 megabits per second available to spare. So 16 up, 16 down, extra. That's recommended. At least they want you to have 10 megabits per second. Then if your bandwidth is metered, meaning you can only use so much bandwidth per month, you gotta watch out for that with your Tor relay. It'll use as much as it can, so you may wanna limit it, and I'll show you how to do this. But you're required as a Tor relay to use at least 100 gigabytes per month of outbound traffic. And according to this, the same amount of incoming traffic as well. So 200 total, right? I think that's what it's saying. And again, if you're running this at home, you will need a public IPv4 address. You won't need a static one, but it will either need to be directly on the host, which is rare, or it's gonna be behind NAT, which is the most common. And you'll have to do some port forwarding. I'm not gonna detail that here, but just know your router normally has, this can be my router right here. Your router normally has the public IPv4 address. Let's just say it's 104.25.8.2, and it shares that with all the devices in your home. So if you're running your onion relay, you'll have to make sure that when people hit port whatever, maybe port 80 on your router, it's forwarded to your onion. But again, I'm not gonna detail that here. Now, if you're an absolute mad lad and you wanna run a ton of Tor relays in your house, you're limited to 8 per public IPv4 address. So don't go too crazy. And then as far as server requirements, it's not a lot, which is why you can run this on a Raspberry Pi. We're talking 512 megabytes of RAM. Disk storage is nothing, you just need 200 megabytes of spare storage. Any modern CPU is fine. And finally, uptime. If you're gonna be running a Tor relay, the goal is that you have it up 24/7. Available. You don't have to, but ideally that's what you're doing this for, right? But if anything, you wanna make sure you're doing it for at least 2 hours a day. Otherwise, it's kind of like not very useful. Now, one more note on running this at home on your own hardware. I said earlier that guard nodes and middle nodes normally don't receive any complaints and any fuss about anything, but that's normally. It doesn't mean it can't happen. Just be prepared for that. You might get a DMCA notice or some kind of copyright notice. And even then, it's not the end of the world. A simple letter or email to your ISP or whoever's complaining can smooth it out. And the Tor project does have email templates you can use, just copy and paste, send that to them. But just know that's a possibility, while it is small. Now we're gonna start setting up our Tor Relay in the cloud. And if you wanna set it up at home, just follow the steps. It's pretty much the same. Now I'm not gonna recommend any particular cloud because some clouds don't really like you running Tor relays on their network. To find out which ones are good, the Tor project does have a list of good, bad ISPs. Pretty exhaustive, just go through them all. Here they'll tell you if you can run a relay or an exit node. Most of the time, they're not gonna care if you run a guard or a middle node. Exit is really what they care about. And if you really wanna make sure, just talk with the chat. Put a support ticket in and ask them, hey, can I run one of these types of relays? Now for me, I'm gonna use DigitalOcean to run mine. And also keep in mind as you're choosing your hosting provider, your cloud provider, the Tor project wants you to try and avoid these because they're overly saturated. The goal here is to have a bunch of onion nodes throughout the world on all types of networks. And if we have a bunch of onions all in one place, it kind of limits its effectiveness. We want to spread out. Now for me, I'm going to choose DigitalOcean to run mine. Again, I'm not recommending you use this, it's just an option. And you should definitely check with them yourself if you're allowed to do this. But the cool part is it's ridiculously easy. Okay, so now that we have all the legal stuff out of the way, let's make an onion. Here are the steps. Step 1, set up your server, right? In the cloud, I'm going to set up an Ubuntu machine. That's Linux. I'm going to put this in London. Sorry, that was my best British accent.
No. Ron, no!
I need to watch more Harry Potter. I'm gonna choose the latest version that DigitalOcean has, 2304. I think that's Bookworm, actually. I'm not sure. And then for the size of my virtual machine here in the cloud, I'm gonna go with the $6 a month machine, which has 1 gig of RAM. And then notice with like a lot of cloud providers, we have a limit of how much data we can transfer. We're capped at 1 terabyte on DigitalOcean. Whatever you're doing, find that out. We're gonna add that config later on. And if you're at home, go ahead and set up a VM or whatever you want to run that's similar to this. I do recommend Ubuntu. It's my go-to, I love it. I'll set up a password and name it something cool, middle child. And what am I forgetting? Oh, my password sucks. Try it again. There we go, it likes that one. Nick, please don't show my password. Now I'll create my server. On that note, I also recommend you run a dedicated server or whatever it is for the Tor Relay. Don't have it running on your main machine or a machine that you use for other purposes. That being said, you could probably run this as a Docker container. I haven't tried that yet. Let me know in the comments if you can do it. While it's booting up, let's take a little coffee break. It's my first cup today. Okay, the middle child I think is ready. I'm just gonna jump into him and grab his IP address so I can remote into him. I'll launch my terminal, SSH root at the IP address of my server. Do the same thing for you, whatever your username is. And we're in. Now for step 2, we're gonna set up what's called unattended upgrades, or just auto upgrades. And this is kind of a nice step because what it will do is make sure that your system that you're running your onion relay on stays up to date with all the latest and greatest stuff, especially the Tor version of the software. And it will do this automatically, you don't have to worry about it. That's the kind of magic I like. So let's set this up right now. The first thing we'll do is an apt update. This will update all our repositories, and we're good to go. Now notice real quick, it does say I have packages I can update. And you might be tempted to run apt upgrade. Don't do that just yet. I wanna test something. Next we'll install the unattended upgrades package. So apt install unattended -upgrades. And we'll also install apt-list changes. Ready, set, go. Hit enter to install, and we're good to go. Next, we're going to edit a file. And I will have all these commands below, so don't worry. We're gonna use good old nano to edit the file. So nano, and the file will be in etc apt, and blah, blah, blah. I'll just copy and paste the rest. So that file. Hit enter, and the first thing we're gonna do is remove all the current config that I see right here. So just kind of all this stuff. And we can do that really easily with nano, with the Control-K keyboard shortcut. So Control-K, bam, it knocks out the whole line. Bam, 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 bam. Okay, it's gone. And now we're gonna copy and paste some stuff that I'll all have below. Copy and paste that, which is telling it what distros to auto upgrade. And then we're adding this line of config, which will allow it, and this is optional, to reboot and come back up on its own for the upgrades. Kind of cool, hands off, I love it. With that in place, we're gonna exit nano. Control X, Y, enter to save. We're good to go. Almost. We have a few more things to do for unattended upgrades. Next, we're going to edit this file. I'm gonna do nano, this file right here. Again, this will all be below. I'm going to remove everything I see here and copy and paste all this stuff. Just configuration options for unattended upgrades. Control X, Y, enter to save. And that's it, it's configured. And now what we wanna do is just test it. And we'll do that with this command. Unattended -upgrade. And we'll do a -- or tick debug. Not tech bug, debug. There we go. What this will actually do is update, and it will reboot. So you get a good test of like what it's doing. Ready, set, go. Lots of stuff, perfect time for a coffee break. And I just love watching terminals, don't you? And just like that, it rebooted. So I'm gonna wait for it to come back up. So step 2 is done, now for step 3. And here we're actually going to install Tor. This is where the fun starts. And it's really not that bad. Kind of easy. I'm gonna see if I can connect back to my machine. If it's back up and running, it is. And I'm in. Now the first step in installing Tor is adding the Tor repos to our repository list. First we'll do an apt install apt-transport-https. I already have it, you might already too. If you do, hit that like button. Next, we're gonna find out the version of Linux we're running right now, or the Debian version if you installed Ubuntu. So I'm gonna cat a file, cat etc debian _version. Cool, so it is running Bookworm. Yours might be different. Just remember this right here. Now we're gonna create a new file. We're gonna use good old nano again, so nano. And the file will be in the sources.list.d directory, and we're gonna name it tor.list. So it'll look just like this. Hit enter, and we're gonna copy and paste some stuff. Again, commands below. And paste. Oh, I do not like that being out of line. Let me just move that over. Ah, perfect. Now there's two things you want to update here before you save it. Right here where you see your distro. You want to remove the curly brackets, the braces, and put in your distro name, which we just catted just now. So I'm just gonna remove that and put in Bookworm, just like this. Same thing for the line below. So this right here is our repositories that we're adding for Tor. We'll hit Control X, Y, and enter to save. Next, we're gonna add the GPG key with this command. This will allow us to trust this repository so we can pull down the stuff. Add it. And now we're gonna update our stuff, our packages. apt update. You'll notice it's actually looking at the Tor project right there because we just added those. And then finally, we're going to install Tor. Here we go. apt install Tor. And we'll do deb.torproject.org-keyring, which is adding the necessary keys so we can, again, trust the Tor project. Ready, set, go. Do we want to continue? I sure do. Hit enter. And it's almost done. I think it's done. Now, just so you know, you installed Tor. Nothing's happening yet. By default, it's just kind of like, configure me, please. Like you can't, it's not doing anything. You have to make sure it runs. And that's gonna be step 4. Let's configure Tor. Did that rhyme? I didn't even plan on this. So to configure Tor, we're gonna edit a configuration file. The command will be nano etc torc or torrc. Hit enter, and we are editing the Tor network file, or the configuration file. Now notice everything's hashtagged out, meaning that it's not currently enabled. You could go through and enable each one of these. What I prefer to do is just add all the commands right here in an open space, just like what you see here. The first option we'll configure is the nickname, just like this, of our relay. Name it whatever you want. I'll name mine middle child. Next, you'll want to add contact info. So just like this. This will be your email address. Now, I will say this. Make a new email address for your Tor relay. Make one that's dedicated to Tor that does not identify you in any way. I did that. I'm not gonna show you mine because then that'll identify me to you. I'm not too worried about it though. Next, we'll do the OR port, which is the port that the Tor relay will listen to for incoming connections. So that's your gateway into, or other people's gateway into your network, into your relay. Now, if you're doing this on a server in the cloud, it's not crazy important. I'm just gonna run this on 443. One of the defaults is 9001, so you could do that. Just keep in mind that whatever you run, if you're running it in your house, you'll have to port forward that. For me in the cloud, 443 is perfect. Now this next option is very important. It's exit relay, just like this. You want 0 for no. We do not want to run this as an exit relay. If you wanted to do that, you would put 1, and no, we're not doing that. The next one will be SOCKS port. For me, I'm gonna put 0 because I don't wanna run a SOCKS proxy. It will run by default. If you don't know what that is, just put 0, don't worry about it. This is for if you only want to run Tor on this relay. Now this is all you need for basic setup, but if you're like me and you want to put in some bandwidth restrictions, let's add that right now. So I'll just put a little section marker here, bandwidth stuff. And again, they have all this config down here and you can look for it. I don't want to bother with trying to find it. I'm just going to add it right here. The first option will be accounting max. This will be the total amount of bandwidth I want my Tor relay to use for a given period. Now for me, I'm going to set it up for a month. You can actually change it for a day or for a week. But the month is probably the best because that's how people charge for things, right? Your ISP and your cloud provider. For me, I'm gonna do 800 gigabytes, keeping me under the threshold of 1,000 gigabytes or a terabyte on my cloud provider. Next, I'll define what my period is. I'll do that with the accounting start, and I'll say month. That's my period. I wanna start on the first day of the month at midnight, 0:00. Now, I'm not gonna detail it here, but if you scroll down just a bit, we'll get to the section on bandwidth. Here it details more control over how much bandwidth you allow each day, the speed, you can throttle traffic, control bursting. So for example, if I uncommented this command right here, I would only allow speeds of 100 kilobytes per second. And then maybe I allow this one which would allow it to burst up to 200 kilobytes per second. But because I'm running it in the cloud, and I'm not using it my own bandwidth at home, I don't care too much. But for you at home, if you want to control that, just uncomment those commands. And I'll show you a way you can actually visualize this here in a bit, and actually gets us to our next configuration option, monitoring. I'll just do a little section here, monitoring stuff. Now this is for in a moment, for future us, because we're gonna install a monitoring program that'll help us visualize our Tor relays. These two options we're gonna add right now. Control port, and we'll say 9051, that's the default. We're opening up a port to our monitoring service. And then cookie, that may be hungry, as I said that. Authentication, 1, allowing it to authenticate with the cookie that we're currently using on our server here. Basically not having to use a password. There is another option to use a password. I'm not gonna worry about that right now. Now this is all we need. I'm gonna hit Control X, Y, enter to save. My configuration's ready to go. We're almost there. I'm gonna do two things. First, I'll do system CTL, enable Tor. This will enable Tor as a service or a daemon, so it can run in the background. And then we'll do system CTL, restart Tor. And that's it. So right now, currently, Tor should be running. Let's just make sure. We'll do a system CTL status Tor. Yep, if you see active and enabled and everything looks good like that, you're solid. But now let's get some actual visualization. I wanna see what's happening. For that, we're gonna install a program called Nix, or NYX. apt install Nix. Very simple. It's gonna install in a few moments. Little coffee break, not too long. And it's done. And now all we have to do is type in NYX or Nix, and we are visualizing our Tor relay. Now I love this, and just a couple things you can see right off the bat. You can see your Tor name, IP address, the control port, and authentication method. You can see that your Tor version is recommended. See how much CPU and stuff you're using. Love it. Even your PID and your uptime. Beautiful graphs on the download and upload. Love that. And then the best thing I think is right here. You can see your restrictions you put on bandwidth. So we have the total amount used versus what we set, and then when it's going to reset. And then just in case you were worried about it, exit policy, reject. We're not doing exit nodes at all. We're not doing that. We're good. We're good. Don't worry about it, buddy. Now, while we're sitting here in Nix, we can hit the M key on our keyboard and access the menu. And if we scroll over to view with our directional keys, we can look at different things like the connections. And we can actually start to see the circuits. Look at that, guard, middle, end. It's so cool. These are all our connections. We can change our view to our config and see every option that we have configured. So you can just kind of make sure you did everything right. And then to exit, just hit Control C. That doesn't stop Tor from running, that just stops you from visualizing it with Nix. Now I want to jump back in there and show you one more thing. Notice up here, and this is kind of the life cycle of a Tor relay, because like I said, you will graduate to guard node eventually if you're awesome. But how do you become awesome? How do you know if you're awesome? It's by the flags. It's always about flags. I don't know why I said. Right here, we have no flags. We're fresh, we're a newborn baby, we're a middle child. This will change over time. Now I've been running a couple Tor nodes in the cloud for a minute. Let me go bring them up. On this one, I have a running flag and I'm valid. And that came from just leading it up for a minute. It tested my bandwidth, made sure I was reliable. And here's another one, which I've got a special flag. Dude, I'm fast. How nice is that? Your Tor relay will actually go through a life cycle. Initially, it's really not being used for much. In fact, the first 3 days, you're just waiting for a bandwidth measurement. In phase 2, remote measurement, days 3 to 8, you're operating, you're a middle child. You don't have the 20 kilobyte cap like you do in the initial phase, the first phase. And you'll attract more traffic, but you're limited because, hey, you're still the middle child. Now things get exciting in days 8 through 68. And this is a maybe. They're gonna look at your bandwidth, weighted fractional uptime, time known, basically variables to see how good you are. And if you're good, you'll get that guard flag. You'll be that first hop. And once you've been a guard for 68 or more days, where you reach kind of a steady state, you're a veteran. You're an amazing contributor to the dark web and helping people around the world stay anonymous and safe. Please comment below and say, hey, yeah, I set up a Tor relay. I'm in the cloud. I think it's cool what this is. I like the idea. And sure, the dark web can be used for bad things, but I think it's mostly used for good things. It's all about your motive. And I know my motive here in supporting the Tor project and running a relay is to help people stay safe and private and anonymous. I'll see you guys next time.